In this video, we're going to focus on importing the EdgeTech JSF files that have merged navigation and attitude information in them. The first thing we have to do is create a Sonarwiz project. We'll go to this plus mark here for a new project. We'll tell the project name is going to be Sentry 386. We're going to look at where we wish to store this and have the software write files. In this case, we're going to put it on our data drive underneath the DSL project, not underneath data, but underneath processing. There's a folder I've created called Sentry 386. There's multiple ways to get the UTM projection zone. You can enter it in by hand, you can select the local city, or you can go get it from a file. That is the normal way. In this case, we navigate to the proper dive, 386, Sidescan sub-bottom, raw JSF with nav. You have to go to the files that have navigation in them. If they don't, it will just default to its older setting. Once you do that, it will import, say, your latitude and longitude. That makes sense with this project. We will also make sure we always update the fish position, and we're going to change the time constant for course smoothing. In this case, we want to set it to 3 pings only. Typically, the default value is 300. In this case, all the nav data in the files have already been processed and smoothed by DSL code. We don't want to oversmooth. Now we've entered this information, we know that we're in UTM zone 19 north. So we can go ahead and create our project. The next thing we're going to do is go over to the import tool. We're going to import Sidescan data. We have to again browse to where our data is. Raw data is underneath Sentry 386, Sidescan sub-bottom, raw JSF with nav. There's a number of file options that we have to look at as well. We click on the file, we can go to JSF files, which is what we're importing. We want to make sure we are importing the entire envelope. We're applying the ADC gain from the JSF sonar packet file. Group coordinates is the default and what we want, and sonar ping is the default for all these settings in the source of where we get our heading data, time source, and our depth source. We also have the option for advanced settings. We're going to import 100% of the range that we wish. We have the option later to change that. We don't want to split the files at time gaps occur because that should have been dealt with already, and we're not going to do anything with far field. You want to make sure you change the samples per channel from the default 1024 to the maximum resolution of 4096. And again, we want to make sure our time constant for course smoothing is only 3 pings so we do not oversmooth the headings. We will also try to make sure to use the sensor heading rather than, of course, make good for projecting the sonar data. We also have the options of importing channel 1 and 2, or 3 and 4. DSL data typically has low frequency, or 120 kHz on channel 1 and 2, and the high frequency, 410 kHz on channels 3 and 4. In this case, we're only going to look at the low frequency. Now we have UTM zone 19 north, channels 1 and 2, and we're going to import all of these files here. And as you can see, you're starting to import the data, and it will give you any error messages necessary. As it shows up green, everything is good. Once the data finishes importing, it will show up here on the left-hand navigation pane. You see all your different files that you have here. Over here, it's plotting out the actual side scan, which at this time we're not really looking at. So we want to go to View. We want to go to Drawing Mode, Side Scan Drawing Mode, and go to Navigation Plot. And this will show us just the track line. First thing we're going to do is go to the Drawing Mode and set the track line color to something that's a little bit easier for us to see. There we go. Now you'll notice that this line is 232, 33, but 228 is down here, so they're out of order at this time. First thing we can do is go ahead, right-click on any of these, go to Sonar File Manager, look at the names, and we see that they are out of order. If we sort them by file names, now we can see it starts with 228 and goes in order, but nothing's changed over here. Until you hit the drawing that says Set Drawing Order, it won't change. Now that you've hit set drawing, you can come over here and notice that 228, 229, and everything is now in order. So we can go ahead for now and close this on our file manager. Another thing we want to do right off the bat is verify our navigation and attitude data really is in here. Obviously the navigation is because it's plotted up pretty accurate to what we think it should be. If we go and look at the plot from the DSL nav plot, we see that this matches this. So our data is located in the correct place, and the JSF files have the correct latitude and longitude. We will also right-click on here, go down to navigation for any file, and now you'll see the bird's eye view of the plot, XY plot of where it is. And down below, you can look at a number of different things. In this case, you're looking at the altitude of it. You can also look at the water depth and see what the Sentry's water depth was. You can choose lat long, heading. All these different options you can look at just to verify that the attitude information in the JSF files is accurate in what you think it should be. The next step to look at is to get rid of the files that we don't think we really need. In this case, we probably don't need the first file where it was still going through the water column before it got onto the survey line. We also noticed that you have this larger scale survey that was done at 30 meters altitude, whereas you have this fine resolution survey at 5 meters altitude. In this case, we're looking at 120 kilohertz data, so we don't want to keep the fine resolution survey, we want to keep the large scale survey. As I highlight this file over here, it shows you where the files are here, highlighted in red. In this case, we don't particularly want that file, so right-click on the file, so we can say delete from our file. Yep. Now we also want to find this file. That one, we only want the first half of the file, and we want to get rid of the second half of the file. But for now, we'll just get rid of the simple one. Select this line in the left-hand pane, hold your Shift key down, and use your arrows. And you can slowly highlight through and choose all the files in this lower altitude survey. Once we've chosen those files, we right-click, we delete, yes, and it redraws. Next, you select the line. You can go to the navigation pane, right-click, and say split. In this case, we'll use auto split because it's a pretty good tool that figures it out for turn. Or you could use the mouse to actually select where you want to split it. In this case, we're going to just select it and say if the angle is over 50 degrees, please split the line. And we'll break it into two separate lines. Now you can see that it's broken up into two separate lines. Instead of having line 253, you have 253.0 and 253.1. 253.1 is the one we don't need. 0 is the one that we do need. Now we can go ahead and delete this line. You can also now go out and zoom to fit all the sonar data in. Looking at a navigation mode, you can flip through here to see where we are, what data. We have the cross line, another line, and then we begin the survey. For now, we'll leave the cross lines in. Typically, you would not. Once you verify that the data is good, you would take them out for the mosaic. This concludes this portion of this video that was focused on importing the JSF files to Sonarwiz.